Hi, I'm Namra Chauhan. I'm in section 2 of Professor Gabriel's 330 class. Today I'm going to be demonstrating the remote DNS attack for you guys, also known as the Kavinsky attack. So the first thing we're going to do is we're going to want to make sure that we have 3 virtual machines running. One is the user, one is the server, and one is the attacker. So the first thing we're going to do is we're going to make sure that we have our lab environment set up. So we're going to go over here, we're going to go to the user machine, we're going to open up our terminal, and we are going to do cd etc resolve conf. Then we're going to do cd resolve conf.d. Then we're going to make sure to go ahead and create a header file. So in this file, we're going to make sure we have a DNS name server .8. This name server is basically the DNS server of our server VM. So if we go over here, open up terminal, make this a little bit bigger so you guys can see, and if we look here, this server is .8, so we know that whatever the user sends over, the server will receive. That's so we know that. So after we have that, we're gonna write and quit this file. So then we're going to want to go back to our user machine and basically reset our network. So we're going to do that by doing sudo resolve conf -u. Okay. Then we're going to come back to our server machine, and so we need to set up our local machine. So we're going to do that by going doing cd etc bind, and we are going to create a name.conf file. So sudo vim named.conf. So over here we're going to want to make sure that we have the zone attacker32.com set up here. So this is basically saying if you find this domain attacker32.com, then we're going to forward that DNS request to this IP address, and the 10.0.2.5 is actually the IP address of our attacker machine over here. Yes, so right here, 10.0.2.5. This is the attacker VM's IP address. So essentially, we are forwarding the DNS request to this IP address. So after you have that, you're going to want to write and quit out of there. So then we're going to go to our server machine, and we are going to restart our server. So we're going to, do sudo service bind 9 restart. Okay, so now both the user and the server machine are set up. So the next thing we're going to do is we are going to set up our attacker machine. And over here, we're going to be in the bind directory as well. So we're going to change that. So cd etc bind. Then we're going to want to modify the name.config file. So conf file. So we're gonna go sudo vim name.conf. Okay, so in this file, we're gonna set up two zones, attacker32.com and example.com. And we're gonna save these two files over here. In these two. So after we have that, we're gonna write and quit and go back here, and let's view these files. So cat attacker32.com.zone. All right, so over here it is shown that our domain name server, or our DNS server, is attacker32.com, which is good. And over here it shows that our IP address is .5, which is good. That's what we need. Then let's take a look at our other file, example.com. Oops. Same thing here. Our DNS server is example.com, which is good. That's what we need. And the IP address that was assigned is 1.2.3.5, which is good. That's what we need. And again, our server is .5, which is good. That's what we need. So then what we're going to do is we're going to restart our bind. Oops, restart. Okay, so that's good. I'm going to open up Wireshark on the server machine real quick to show you how everything is working. So let's get this started. Okay, so first we're going to analyze what's actually happening, and then I'm going to talk about how the DNS is going to poison the cache. But first we need to look at how things function regularly. So now that I have Wireshark running, in order to demonstrate that everything's working the way that it's supposed to, we're going to go to a user machine and we're going to do dig at 10.0.2.5 example.com. And this is going to show us, if we go back to Wireshark over here to look at how things are working, this is going to show us that 10.0.2.6 over here is talking to 10.0.5 over here, asking it, okay, so where is example.com? And then 5 is responding back with, oh, that's NS attacker32.com. So if we go back here to our user machine, we can see that 1.2.3.5 is example.com's IP address, and the DNS server is 10.0.2.5, which is this right here. So we can see that everything is working correctly. So now we're going to go to our attacker machine and we are going to analyze the files that we have over here. So I'm going to open up my Python files, the query file, and I want going to open up the reply file. Okay, so in these two Python files, I have used Scapy. So I have used Scapy here, and Scapy all over here. And we need to generate a query, and then we need to generate a reply. So for that, we're using Python and Scapy to generate both packets. And we can see that in the reply file, we have everything good to go. The destination is .8, which is just what we need. And the source is .53, which is the example.com's DNS server, which is good. Our port is good. Our target names over here, we just needed a 5-letter random domain name. Target name is good, example.com. Over here, ANS A is good, NS is good, type NS is good. So that's what we have. Then we're going to take a look at our C code, which is how the attack will work. So this is the attack.c file. So if we look at our attack.c file, we can see our target AP.8, which is good. We define our IP header over here. And if we go down, this is a basic skeleton code for the attack, but if we go down, so if we go down here to this meme copy line right here, so what we're doing over here is we're getting a name, okay, right here, and then we are randomizing that name. And what this meme copy is basically going to do is we are going to change the 41st offset for our query, and this will change that random 5-letter domain that we looked at earlier over here, the QWERT. That's going to change that. So then we are going to do the same thing for the response over here. And then over here, we are going to do 64 for the other part of the message for the response. And then what we're going to do is we're going to send a DNS request. And then we're going to go into the for loop for the transaction ID, which is going to start at 1. And we're going to go up to 2500. So basically what we're doing is we are changing the offset ID over here to 28, and we are going to send a bunch of responses to our this is going to send a bunch of DNS responses, and I'm going to show you this in action right now. So if we go back to our terminal here, and if I'm going to start Wireshark, So stop this, start this, and I'm gonna launch the attack so you guys can see that. So, oops. Sudo attack. Oops. So to demonstrate, I'm gonna run sudo attack, and I'm gonna start over this Wireshark thing just to demonstrate. So this is, oops. So this is gonna run, and these are all the DNS responses that are being sent to our server right now. So I'm gonna stop this, that's enough. And if you look in Wireshark over here, we can see over here that .5 is sending, our first packet is from .5 and it's sending it to our DNS server, which is .8 over here, and it's asking, hey, where is the website of dydv.example.com? Then we start sending a bunch of spoofed replies over here, and if you go down, these are a bunch of the spoofed responses, the replies, quite a lot. And I'm trying to, oh, okay, so if we go down here, we can see that .8 is sending a DNS request to .53 over here, which is example.com's IP address, and the transaction ID of that is 0x6c7. So essentially what we want to do is we want to send spoofed DNS responses with different transaction IDs, which is this over here. These are all different transaction IDs. Before we want to do we want to send different transaction IDs before the server replies, and we can see here that .8 tells if we go down here, quite a lot. So essentially we can see that .8 tells .5 that, hey, you know, this domain doesn't really exist. Why don't you go and ask example.com's actual DNS for any other domain names inside of example.com. So we've looked at Wireshark. So we are gonna go back to terminal, and so the crazy thing here is we need to guess the transaction ID. So what we're going to do is we're going to want to dump the cache file and view it. And in order to do that, we can see that our attack was successful. So then we go to our user machine and we do dig www.example.com and see example.com gave us 1.2.3.4.5, and this is our domain name. So we have successfully poisoned the cache example.com, because example.com got cached with ns.attacker32.com, and that is the